Hello everyone, and welcome to this second section on human population in the critical thinking course. Last week we looked at the classic demographic transition model as a theory to help us understand how human populations change and some of the possible reasons for why they change the way they do. This week I'd like to ask the question, is it really human population that's the main problem? Or is there more to it than that? Is it simply the case that we need to reduce the total global population by reducing fertility across the globe? Or are there other factors that are as important in addressing the global challenges that you heard about in The Perfect Storm? To begin with, let's think critically about the size of the human population. As you saw last week, our population stands at something over 7 billion in 2012, and we can anticipate that it will rise to around 10 billion or so by 2050, and it's expected to stabilize or begin to fall thereafter. While this is an enormous increase compared to our population until just a couple of hundred years ago, what does it actually mean in terms of the space we need to live in? As you know, we already have over 20 megacities on Earth, each with a population of over 10 million people. In fact, as you can see here, a world population of 10 billion people could actually be accommodated on any one of the 5 continents, at an average population density that is less than that in a major city like New York, for example. So space on the surface of the Earth to accommodate the human population is not really the limiting factor. Instead, it's the impact of the human population and human activity on the rest of the Earth and its resources which is the real problem. Population is part of the problem, but it's not the whole story. It might not even be the most important part of the story. Many sociologists, economists, and scientists have tried to find ways to measure the impact of human activity on global environment and global resources. That is, to come up with a rational understanding or a theory that describes this complex relationship. A long-standing and general theory that attempts to describe the impact of human activity on global environment is summed up in the following relationship, the IPAT equation. The IPAT equation was first proposed in the early 70s, and since then it's been restated in many different variations. At first sight, it's fairly straightforward, even rather obvious statement. The IPAT equation says that the impact on the environment, I, is related to the population size, P, multiplied by the affluence, A, which represents the materials consumed by the population, and then multiplied by the technological cost, T, of producing the materials for consumption by the population. Or another way to describe this relationship, which is what we can use for our purposes, is to say that the environmental degradation is equal to the population size multiplied by the consumption per person multiplied by the environmental damage per unit of consumption. Clearly, this is a theory that seems to fit in with common sense. The higher the population and the greater the demands on the environment, the greater will be the impact and degradation of the environment. So this equation tells us that it's not only the size of the population that matters, it is also important to take into account the consumption of resources. That is, things that are consumed by the population, such as food, fuels, water, and material goods, ranging from fizzy drinks to mobile phones, designer shoes, and cars, and the environmental costs of producing these material goods in terms of pollution, the depletion of finite resources, and so on. The equation also tells us that these factors should be multiplied together to produce a compounding effect. The environmental impact is therefore not just due to the size of the population alone. In fact, the other two factors in the equation, A and T, could have a much bigger environmental impact than population itself. However, although the IPAT equation fits with common sense, it has some serious limitations. There are several important shortcomings. First of all, it is too simplistic in assuming that the three variables P, A, and T can simply be multiplied together. So, for example, a doubling of population P should mean that there should be a doubling of the environmental impact, but in reality that is rarely the case. Also, it's not always easy to separate and define what we mean by affluence, A, and the technological cost, T. And it's also not clear how we can measure them. And it's often the case that there are changes in the pattern of consumption that have a much bigger impact on the environment than actual affluence itself. The limitations in the IPAT theory mean that its usefulness is also limited. You can explore the usefulness of the IPAT theory in this week's exercise for yourselves using the specific examples that we have provided. For the moment, let us go back to trying to use the IPAT theory to anticipate what might happen in the foreseeable future. As we saw last week, the total human population is expected to rise to somewhere around 10 billion in the foreseeable future. This rise in population is not evenly spread around the world. In Asia and Africa in particular, the population is increasing, as is the development of the economies in these regions, while the population of Europe and the Western developed countries is either stable or it is gradually declining. Historically, the IPAT equation has been used to relate the environmental damage to human population and human activity. For example, to explain the increase in lead pollution from the increased use of cars in the developing world, and now increasingly also in the developing economies in Asia in particular. So historically, all three of the variables in the IPAT equation, P, A, and T, have been increasing with an increasing impact on the global environment. If we want to reduce the environmental impact of increasing human population, reducing fertility in the developing areas of the world by promoting birth control and women's rights, for example, would reduce the rate of population growth. However, the IPAT equation tells us that we also have two other ways of reducing the total impact. If we could reduce either A or T or both, then the total impact would also be decreased. So in the developed world, we could take measures to reduce consumption and also reduce the environmental cost by using more eco-friendly means of production and distribution of the materials and goods that are consumed. In the developing world, the impact of an increasing population and an increasing affluence could be balanced by avoiding environmentally damaging technologies and using eco-friendly technologies right from the start. In reality, we need to reduce the total environmental impact by taking into account all three variables, P, A, and T, with a different emphasis on each of the variables in different parts of the world. So even though the IPAT theory is not precise enough to meet all the requirements to be a valid theory according to our original definition, it still gives us a good way to think critically about the impact of human population and human activity on global environment. Have a look at the additional materials and the specific examples that we've provided for this topic, And also remember to check out this week's exercise. I hope you will explore this interesting topic for yourselves further using the additional links that are included in the materials provided. Thank you, and see you next week for the final week of this critical thinking course.